Okay, so today we are going to discuss about the enthalpy diagram. Let me write the meaning of enthalpy first. The meaning of enthalpy is heat content. Heat content. Alright, heat content. So let me write here the transforms of matter, or you can say the states of matter basically. So let me write here transforms of matter or states of matter. Transforms or states of matter or states of matter. All right, so the states of matter, let me draw here the arrow so that I can draw the diagram of enthalpy. Here we have some common states of matter. All right, common states of matter. So how many states of matter we do have? We do have 6 states of matter. Let me make here the arrow. We have 6 states of matter basically. So the first state of matter is solid. Second state of matter is liquid. And the third state of matter is gas. The fourth state of matter is plasma. The fifth state of matter is Bose-Einstein condensate. Bose-Einstein condensate. The last but not the least state of matter is fermionic condensate state. Fermionic condensate state. Condensate state. All right. So basically when we provide heat to solid, it becomes liquid. Let me write here. When we provide temperature to solid, it goes under the process of melting, or you can say fusion. Let me write that too. Melting, or it goes under the process of fusion. Alright, by providing the temperature to solid, it goes under the process of melting or fusion, and thus it converted to liquid. If we provide temperature to liquid, that liquid goes under the process of evaporation or boiling. Let me write here the processes. Let me write here evaporation or boiling. When we provide temperature to liquid, it goes under the process of evaporation or boiling. Then it converts itself into gas. Alright. Initially we provided temperature to solid. It has gone under the process of melting or fusion, and it has converted into liquid. Then we have provided temperature to liquid. It has gone under the process of evaporation or boiling, and it has thus converted itself into gas. then providing temperature to the gas. When we provide temperature to gas, and that too very high temperature, all right, not till 60 degrees centigrade or to 98 or 90 degrees centigrade, however up to 3000 degrees centigrade, up to 3000 degrees centigrade. If you provide temperature to the gas of up to 3000 degrees centigrade, it goes under the process of ionization. Let me write here. It goes under the process of ionization. Thus, it converts itself to the plasma. Alright. So, now I'll tell you the process of ionization as well. What is this process basically, ionization? So, let's go with ionization first. Let me take any gas here. Alright. I am taking a little bit down. So here we are going to take the gas of hydrogen first, suppose H2. Alright, basically there are two atoms of hydrogen, which means it will have two protons as well as two electrons. Two protons and two electrons. Making the structure here, we have the central part, which is nucleus, in which two protons are present, and we have these shells in which electrons are present. This one. Alright, now we know that there is an electrostatic force of attraction between proton and electron. Let me make that too. We have basically here an electrostatic force of attraction. Electrostatic force of attraction. So this is basically a binding force which is between electron to proton or electron and proton. Alright, when we provide the temperature of up to 3000 degrees centigrade, this temperature leads to the breakdown of this electrostatic force of attraction. And when this electrostatic force of attraction is broken down, this converts itself to the, wait, let me write here first. So basically this convert, the electrons and the protons both are separated then, just because by providing the temperature of up to 3000 degrees centigrade. So here we have an atom in which two protons have been separated as well as two electrons. Alright, so now we have thus here cations, just because it has positive charge, and we have two anions. And basically this is what we call the plasma. This is what we call the plasma, which is the fourth state of matter, which is made by providing very high temperature of up to 3000 degrees centigrade to the gas, and the electrostatic force of attraction which is present between the proton and the electron has been broken down just because of that temperature of up to 3000 degrees centigrade. Breaking down of electrostatic force of attraction leads to the separation of protons as well as electrons. Thus we have cations and anions, and in the last the plasma has been produced. Alright, so this was basically the process of ionization. This was the process of what? It was the process of ionization basically. Ionization. Now we have an other ionization too at a low temperature. This is at a very high temperature. At very high temperature. at very high temperature. Now we are going to discuss the ionization at low temperature, not at very low temperature, however at low temperature. So let's discuss that now. All right. Ionization at low temperature. Low temperature. Ionization at low temperature. Low temperature. What does mean by this low temperature? Just here we will be taking the temperature of basically 98 degrees centigrade. All right, we are taking the temperature in the 90s here in this ionization. So basically here we have, a compound which is known as NaCl. We all are known about that, NaCl, which is basically what? Sodium chloride. Sodium chloride. All right. So we know that sodium has a positive charge here. Wait. Let me provide the temperature to this first. Okay. If we provide temperature to this, temperature of what I have just told right now, temperature of 98 degrees centigrade. 98 degrees centigrade. Wait, let me highlight this. This is the temperature and this is basically 98 degrees centigrade. So we have provided temperature of 98 degrees centigrade to the NaCl. Thus it has converted itself into the ions. Alright. Na has got positive charge. Wait. Na has got positive charge while Cl has got negative charge, which means sodium is cation here. Sodium is cation, however chloride is anion. So these are basically cations and anion formation as well. But can I say this is a plasma state? Of course this is not. This is not at all a plasma state. Just because plasma state will be made if we will provide a very high temperature of up to 3000 degrees centigrade. Here we have just provided the temperature of 98 degrees centigrade. However, providing the 98 degrees centigrade, the NaCl has been ionized as well into Na positive and Cl negative, which means cation and anion have been produced. Now let's see if we are doing ionization at low temperature. There is a storation of a heat as well in the compound. All right. For example, wait, let me write here. You know what? There is a storing the temperature, storing the temperature in an atom, is called gaseous. Is called gaseous. You must have seen the elements or the atoms of the writing structure is like this: Na positive, G. So we think that this is a gas. However, this is not gas at all. Let me tell you the actual meaning of this today. This is basically representing that this Na is in the gaseous form. Now, how is in this gaseous form? Let me tell you that. Let me go with the process. All right, what we have taken here basically, we have gone with NaCl. NaCl is basically a solid, all right, which is a sodium chloride solid. All right, what we have provided to it in order to perform ionization, we have provided heat. All right, we have provided heat so that ionization can occur. Ionization can occur. After providing heat, we know that the anions are made. Na positive and Cl negative. All right, but here we need to write this G as well. This G is basically representing that these both are in the gaseous form. Now what does mean by this gaseous? When we provide heat to the NaCl, so NaCl we know that have been converted into ions. However, some heat is stored in this Na2. Some heat is stored in the Cl2. So the storation of this heat in the elements or the atoms is what we call the gaseous form, which means now the heat is stored in this Na. The heat has been stored in this sodium atom. So now this is in the gaseous form. This heat is stored in the chloride atom or element. So this is in the gaseous form now. So what does mean by gaseous? The storation of the temperature or the heat in an atom or an element is called gaseous form. So this is basically gaseous form. Gaseous form. This is gaseous form. Now let's go with water. All right, you know what, ionization is taking place with the water as well. Wait, let me write here. The same NaCl compound we are taking, which is a solid, we know, solid. All right, so now instead of providing heat, we are providing here water, H2O. We are providing it a H2O. So again these are converted into ions, Na positive and Cl negative. All right, so now what will we write? This water we know that will be stored in this Na atom or an element too, and this you know what, water will be stored in the chlorine atom or an element as well. So what do we call this? We will be calling this aqueous, which means now we have to write here AQ down to the Na as well as down to the Cl, aqueous. Now these both elements are aqueous. So this is basically aqueous form. Aqueous form. The last but not the least, all right, taking the same compound, NaCl, which is solid. Now we will do the reaction with the help of solvent. Now what is solvent? Solvent is, you know what, a substance which has an ability to dissolve something in it is known as solvent. So now we have dissolved NaCl into solvent. So now it will be, you know what, categorized into Na positive again plus Cl negative. So now what will we write? Because we know that some solvent will be stored in this as well. Some solvent will be stored in the chlorine atom as well. So what will we write? We will be writing here Sol. Sol means solvent elements. Sol. Alright. So we have written here Sol. So I hope these are clear to you whenever the storation of the heat, water or solvent take place in the elements or the atoms. So this was all for today, as we have gone through solid, liquid, gas and plasma today. In the next video we'll be going with the Bose-Einstein condensate and fermionic condensate state.